Unable to execute dex. Method ID not in 0xFFFF 65536.
Have you ever run into this exception in your time as an Android developer? You must have at least heard about the infamous dex method count exception when chatting with other Android developers over beers or drinks. So why 65,536? That seems to be too specific to be random. Well, after you listen to this episode and the next time you're making small talk with your developer friends, you should know why. All right, so let's start off with the basics. What is dex? The traditional flow for writing Java code is as follows. You write your Java code in a text file in a way that a human can understand. That code written by you, the human developer, is compiled down to what is called a class file. This class file is basically machine code or byte code that can be read by a standard Java compiler. Android, as you're probably aware, needs a slightly more optimized setting. The traditional class file needs to be further optimized in order to be read by the Android VM or the Android virtual machine. This Android VM, by the way, is called Dalvik. The class file that is generated from your Java class is taken and compiled down further into what is called a dex file. This dex file is very similar to the traditional Java class file that we just talked about in that it is also bytecode and can only be read by a VM. In this case, the Dalvik compiler. So you probably understand now why it's called a dex file, because it's basically short for Dalvik executable or dex. This dex file is basically the format that most of our non-native apps are distributed. And by non-native, I mean like third-party applications that both you and I write and develop. These dex executables are in turn zipped into what is commonly known as the application file or the APK file, which can then just freely run on different devices. Okay, so hope you're with me so far, because this is where it gets really interesting. The dex file specification limits the total number of methods that can be referenced within a single dex file. When you look at the Dalvik specification, keep an eye out for the invoke prefixed methods, because those are the ones that are used for loading. How do these methods impose that restriction? Well, these methods take in an argument of type short, and this is the primitive Java type short. This argument represents the target method's reference index. Now, all these methods that you write in your classes are contained in the dex file, and they are referenced using an index. And this short argument that you pass, this invoke prefixed method, basically says where in all of that index is your method reference. I'll add a link to the actual Dalvik specification so you folks can have a look at it for your own exploration. Now, what is the size of a primitive integer or the int data type? It's 4 bytes or 32 bits. What is the size of a short data type? It's half of that or 2 bytes, which can basically hold 16 bits. If you think about it, that means you have 2 possible combinations to plug, that is 0 and 1, in 16 different locations. So some basic math permutation, it'll tell you that the maximum number of values you can hold within 16 bits by plugging a different combination of 0 and 1s there is 2 to the power of 16. Take a guess what 2 power 16 is. Yup, 65,536. And that's why you have this limitation, because this argument that you pass through these invoke prefix methods basically only allow for a maximum number of 65,536. So you cannot possibly, in that index, reference a number that's bigger than that. It is important to realize here, though, that the limitation is on the number of methods that are referenced, not the number of methods that are defined. So you can have only 5 methods, but somehow together, if they reference more than 60,000 external methods, you're still going to run into that limit. Along the same lines, this does not necessarily mean that your libraries cannot have more methods. They can have as many methods as they want. You can only reference them in your code to that limit. Okay, here's a trivia question. We say that the limitation is not on the number of methods defined. Yet, if you today go right now, take an empty Android project and add a class with more than 65,536 empty methods, what do you think? Would you still run into this error? Unfortunately, you still will. How do you make sense of that? Here's the catch though. Locally defined methods are implicitly referenced. So by just defining them inside your application, they're kind of implicitly already considered to be referenced. So you're stuck there too. Just remember that in the end, it all boils down to the same reference problem one way or the other. So I know what the problem is. When I see that error, how do I know if I'm approaching this problem or not? How do I find out how many methods I really have? There are a whole bunch of scripts that people have written that allow you to run a command in your terminal shell. All you have to do is just run this command and point it towards your APK, and it'll spit out like all the different methods. The common one is this script called dex method counts, and I'll make sure I add a link again to that in the show notes. It's super nifty because you can provide options like the depth that you want, if you want to filter by only a certain package, because if you want to see only a certain library is causing these problems, it gives you all of those options. Next, and finally, probably the most important question for a long time was always, okay, I've run into this problem. How do I fix this problem? Because library sizes are becoming bigger. Well, that's why starting from Android L or Lollipop, Google natively supports this process called multi-dexing. And multi-dexing is basically this complicated process by which they create more than one dex file and they just like collapse them all together into this single load file. Back in 2014, I think, Anwar Ghulam from the Android runtime team talked to Chet and Tor about this process in a previous ADB episode. I think it was episode 11. I'll add a link to that in the show notes, but I do think it is episode 11. Now, there are some quick pointers to note when you use multi-dexing. For example, if you use a min SDK of 21, then you natively use the Art compiler, which is way more faster and has faster build times, especially if you're using multi-dexing. I'll add a link to the show notes where Google has this nice document on their tools page where they basically provide this technique you can use. It's actually very nifty. When you're actually developing, you use a different product flavor. So it makes use of Gradle's product flavor feature and allows you to use a min SDK of 21 when you're actually developing, and you can use your 15 or 14 for your release applications. So yeah, in the end, all this is just basically great knowledge. More often than not, today, most developers use multi-dexing anyway, so you shouldn't even run into this problem. But the next time you're talking to someone, you might find this useful. So hope you enjoyed this short episode. The next time you have a short conversation with another Android developer and want to make sure you're not given the short shrift, bring up this short discussion. Thank you all for listening, and I will catch you in the next episode.